Recording? Okay. All right. We did it. I still have some of my messy kitchen in the background, so sorry to my my audience here.
The fact that regardless, the OBS setup is half the battle, and like the confidence in it, I feel like there is a really good opportunity here for a dedicated, high quality recording setup.
Just put everything together. I mean, this is kind of what we were talking about. It seems like you can just buy an iPad and then run a podcast now, and it'll have all the things. So for people listening, we have 2 cameras. We have we record on some like massive video thing, and then there's all these microphones and stuff like that, and it's a lot of effort.
It's just a lot of it. It's a lot of effort, but you also don't trust it when it's running. Like OBS, is it recording
the whole time?
I think it is.
Yeah, you always want to glance at your screen and see that everything is working.
So stressful.
So it's a ripe opportunity for disruption, and it's got a little bit of a hardware vibe. It's not going to be a full software startup. I mean, you're going to have to put some things together.
So the new Final Cut Pro for iPad can stream live wireless multicam from obviously only iPhones, right? And then each of those iPhones can have a USB mic plugged into them.
Ah, that's how it works. Yeah.
And so you can kind of cobble this all together, but it's still a little like weirdly jank. You have to plug this microphone or your Shure microphone via a USB-C cable into the camera that is recording you now to sync that all up.
Have you ever heard of this thing, a lav mic?
Yeah.
I wonder how good those are. I always listen. I'm not an audiophile, which is like somebody who can like hear the differences in audio. And I always go to these YouTube videos to like hear differences between mics, and I can never hear anything.
No,
it drives me nuts.
Me neither. I'm deaf as anything. But but if you took so those lav mics, I've heard good things about them, but they're just like the clip-on sort of lapel mics.
That's right. That's right.
I've heard great things about them as well. The ones that I've used have not performed awesomely, but I am certain in fact, regardless of that, half the battle was getting the right audio file, recording, to the SD card on it, syncing that in now my video editing software. The like live multicam recording that is offered in Final Cut Pro on the iPad is game changing if they can make plugging all the devices together, and that means the microphones as well. Really easy.
Do you think you could work from your iPad? This is something I've wanted for so long, is to just be able to like kind of take a tiny thing and go, And a laptop is fine as far as the portability, but then you get somewhere and it's kind of hard to take out. Like, I don't want to take out a laptop on a park bench. Maybe I'm not scrappy enough, but I don't want to take out a laptop on a park bench.
Not that laptop. That's one of the old school 17-inch ones, is it?
Yeah, this is a pretty big one. I have like a 16-inch on the table here. This is pretty big. I went to Costa Rica recently, and I actually didn't take this laptop explicitly because it's so bulky and it's so like, it feels like precious or something. Like, it feels like I have to be very careful with it. I took a ThinkPad instead, which is so like rugged, and I feel like I can throw it around, and I got sand on it, and I was like, just wash that sand off. It doesn't really matter with a ThinkPad.
As I mentioned to you earlier, I'm now running a bottom tier, like the bottom of the barrel MacBook Air. And it's got 250 gig of storage, which is the only annoying part about it, is you like they fill up whatever half of that with just the basic apps and OS.
Yeah.
Right.
Yeah.
But apart from that, God, $850 with whatever it was, $100 off at Costco.
Yeah.
What an insane deal.
It's an incredible deal. And I mean, like, you can do anything with that.
Oh, yeah.
You could build any company in the world with that laptop. I think that's
absolutely,
so cool.
Absolutely.
Yeah.
Especially because I don't know how 100% you work, but more and more laptops are just a thin client to either some training in the cloud or some training on a piece of server kit you have running. You're not actually like literally plugged into the
100%
to work on.
Yeah. So funny thing, when I was in Costa Rica, I also tried to get Replet working, and I tried to do pull requests from my phone. I was like, I really want to be able to do this. And Replet has the right interface. For those who don't know, Replet is like an online code sandbox playground thing. And I was on my phone all the time. Also, I'm like the worst person to vacation with because I'm always on my phone. I'm either doing code reviews with the GitHub app, or I'm like, I don't know, just doing like random things, like talking to people on Slack or Discord or whatever. And so I'm always on my phone, but I can't actually code. Replet is the only company right now that has the right interface to be able to code from a mobile thing, because you're just talking to an AI assistant who is doing the things you want, and it can run commands and it can edit things. That being said, even though they have the right interface, there is still just too much friction. It's still not really there.
Your bandwidth with a thumb only keyboard is just like way too low.
It's part of it, but it's also like there are so many little cracks that the AI can get lost in or not understand. For tscircuit, we use Bun, which is kind of new. It's kind of a new TypeScript runtime.
Yep.
But our stuff is all very dependent on Bun. And it's like, as soon as I go down that little branch, all of a sudden the AI gets 10 times stupider.
Yep.
And then you make one other decision. For example, we use React Cosmos instead of React Storybook. And then it gets 10 times stupider again. And eventually the AI really can't help you that much. But they really do have the right interface. I think if the models were smarter, or they maybe as the models get better, they might pull it off.
When you say the right interface, do you talk to it or you type to it?
You can just type to it, but it has like code review inside of it. It has all the little things you need to be able to operate. I can dive into the file system if I need to. I can even preview the app. They have a runner in there. The other thing, Replet is such an interesting company to me because these guys have been at it for so long, and then it feels like they pivoted everything to AI. And how can you have a company that's around that long and then, it kind of pivot on a dime?
Yeah.
I think Windsurf is similar, actually.
Oh, interesting. Okay. So Replet, if I remember correctly, that's where you do all your code interview. At least,
yeah, a lot of people do code interviews from Replet. Yeah, absolutely. Yeah,
interesting. And now it's all AI based, which kind of nukes the code interview aspect.
Yeah, no, I mean, I think they are definitely moving away from that, which also makes sense because I don't know if you've done tons of interviews, but I find everybody is cheating in interviews. I can't do interviews anymore.
Wow. Okay. The one code exercise, so it had screen recording and stuff that I found someone cheating in, it was just immediate, like, get rid of them. Like, no way are we hiring that kind of person. But granted, that was now about 2 years ago.
Yeah.
And it was just like such obvious, blatant cheating that, you got to be better at it if you're going to be doing it in an interview.
I find that people take advantage of things that, like, I am like empathetic toward, or like human behaviors that you would be empathetic towards. So, for example, somebody will like fake a stutter to give the AI more time to give them the answer and stuff like that. And so it takes me a really long time to parse if they're doing it, because what people do, there's an app that basically you put, so your phone watches your screen and it's also listening to the interviewer. And so it really knows everything that's going on. Yeah. Cause it's a separate device, there's no screen recording that can kind of prevent it. So it's really tricky. This is a bit of a rant, but when I go out to interview again, I think what I'm going to do is put a chat interface in front of the people, and I'll just be, what do you call that person that watches? A proctor. I'll be a proctor. And literally, I'll just be like, talk to the interviewer who's an AI who I've trained to do this interview, so it can be totally consistent, and I can watch for the text field defocusing and stuff like that. Because I don't think it's possible to do my normal verbal interviews anymore.
Interesting. I mean, if you do it face to face, like no longer in front of a laptop, which is,
that's true.
I've always been more interested in like architectural interviews, because you can pick someone, whether they're a sufficient software engineer or not, that's fine. And even if they're like not incredibly good at whatever you specifically want, they can learn those skills as long as they've got their head screwed on straight.
Yeah.
But, and they've got sufficient broad background. But if you talk to someone about general architecture, or in the case of my earlier days at Tesla, I would often ask them an interview question on, and this was for firmware, on electronics. I would say, here is a simple signal chain and input, and it's an analog input. And so it had some protection on the front end of it, some filtering, et cetera, et cetera. And you say, like, hey, here's a snapshot of a schematic. It's just resistors and caps. What does this do, and why would I do it?
Yeah.
And just like, hey, walk me through left to right, like what's going on.
That.
And some people, the curious people, were like, oh, I recognize that. That's a filter, and that makes, and you're like, perfect, awesome. Or like, obviously the great people just say, that's a filter. This is input protection. Yeah. Those are TVS diodes, like done, awesome, great.
I think like, okay, so I have a totally different approach, but I totally agree with your approach as well.
Yeah.
I like to do shotgun interviewing. So I have like 50 questions, and I try to go through them as quickly as possible.
Okay.
And they are extremely like nuance or obscure kind of stuff, but in a bunch of different subject areas. So I'm not going to hammer on like, oh, you don't know this. And I also don't expect people to get many of them right. I expect maybe 40, 50% to be correct. So it's hard, but it's like, you know, it's like if a question's too easy, I throw it out, whatever. So it's like bell curved. And I really like that approach because people who have just like if you've spent 4 hours debugging, you learn something pretty obscure probably in your debugging process, right? And it's like, I want people who have a lot of cycles of that kind of digging.
I see.
This doesn't work anymore though. Not at all.
Because they'll just like wait for the AI to like,
exactly.
Yeah.
Because if anything requires any moderate degree of thought, they'll go, oh yeah. And I remember I interviewed a guy for an hour and a half. My interview is usually only half an hour because I was making up questions on the fly because I was like, there's no way he knows all of this. It took me an hour and a half to ascertain.
You got too many right.
He got them all right. Nobody's ever gotten them all right.
Oh God.
Yeah. And I was like, the questions are insane. They're like,
give me one.
Like, why won't this is where I started to like get him, but or realize that this was insane. I was like, why can't the bun runtime like operate on an embedded platform? Like, so yeah,
Okay.
It's like nobody has ever thought about this before.
Yeah.
Right?
Yeah. I mean, so I don't really know enough about bun for this all to make sense. I've never used bun myself, but if I remember correctly, it's like a underlying like React JavaScripty type front end.
That's right.
For front ends, sorry. JavaScript framework for front ends. And so why wouldn't you run it on an embedded device? Well, one, it's going to require an inordinate amount of resources, I imagine. And
at
two,
least 100 megabytes. At least. Yeah.
And two, because, well, you're going to need like all sorts of GPU backend to actually render everything on a display that warrants a bun runtime. Right. Okay.
Yeah. There's tons of stuff. But
and so what of his answer got him?
What gave him away is he answered so specifically. He like so precisely. And I was like, this, you know, none of this makes sense.
Okay.
And also, if he was getting all of my questions correct up until that point, this guy would be pulling not an entry level role, which is when he was interviewing.
Okay. Yeah.
I mean, that's like a bad thing to say to some extent. But.
Yeah. No. Well, I mean, it's true. Like you shouldn't. It's actually suspicious going too low in some cases. Yeah. You gotta know your worth. Otherwise, people are like, are you actually worth it? You got to be confident in yourself. Oh man. What a rough time. Interviewing these days is, I'm sure, just an insane process. And one that, you know, people go both ways on the whether you should work in person or not.
Yeah.
At Atopile and Tesla, full in person all the time. And at tscircuit, it's remote 100%, right?
It's all remote. I do want to have an office for a lab eventually.
Yeah.
But we'll probably just do like people kind of come in for an offsite or come in when they want to. And like, yeah, like as long as we're somewhere that doesn't suck, like San Francisco is a place people generally like to visit.
Yeah. Because as long as they're let into the US and
okay, so that's a huge problem, right? Is like,
and an increasing one.
Yeah, I want to bring in one of the people on our team to come to open source.
Oh yeah, cool.
But I don't know. Hopefully it happens, but
I mean, it's unfortunate. This is the follow-up question, but where are they from?
They're in India, so
that might be hard.
That's going to be
because I don't think they get STVs or Esters. So, oh no. Yeah. What a mess. Okay.
And open source is such a like laid back conference too. In some ways, I'm like, it's not, you know, it's not like they're gonna have all the proper letters and all of that. I don't know. Maybe I'm wrong.
Yeah, I mean, the biggest part is, so as far as I understand it, you can't get a visa waiver from India to the States. I could be completely wrong about this, but that's what we typically get if you turn up as an Australian in the States. You have the electronic authorization that's just pre-validated. You do on your phone, and you're good to go. And the same as you as American going to Australia. And I don't know why, but as my understanding is that India does not have the mutual agreement to do that, and so you have to go to the office of it's not Homeland Security, it's the consulate in, you know, a number of cities, I imagine, and, you know, get a spot, get an appointment, wait in queue, travel, I see. And so it's just difficult, but I could be wrong about that. That's
really, no, that checks out with my experience. I've tried to bring people over a couple times for like conferences or whatever, and each time it's been pretty difficult. I tried to bring somebody from Poland.
And that was hard?
It was hard because they were a Ukrainian who fled to Poland. I think that's why it was difficult.
That's so interesting there. Okay. Yeah. Wow.
Because I don't think they were. I don't think they were convincingly Polish enough where they might be like, "Oh, you might come to the U.S. and stay," or something like that.
Oh, suspicious.
That was my impression of it. So
Oh, damn. It's a wild world.
yeah, it's unfortunate. But speaking of portability, I've got something for you.
Please do show me.
So
You promised some goodies today.
I did promise some goodies. Okay, coding without a laptop, 2 weeks with AR glasses and Linux on Android. So
Okay.
this guy, he puts Linux on his, I mean, every Android device runs Linux, right?
Yeah.
But he sets it up with Chroot so that he has a proper development environment.
Oh, no. Wow.
Gets the Nreal VR glasses. He hooks these up to his phone and he just goes places for 2 weeks. He just works on this setup.
Okay.
And my impression of what he was doing, he's using Dart and Flutter. He's probably building mobile apps or something like that. And this is kind of what the view looks like from the VR glasses.
It's very much not the boring blank wall in a room with nothing else in it that someone like Linus Tolvards would code in, right? Or like they advocate for startups, Wayne Crosby as well.
Yeah, it's the opposite. Like you've got all this stuff going on in the background, right? You feel like you're actually somewhere.
Yeah.
Best live background you could have.
It's a live background. I've always, I mean, I don't know how you feel about transparent windows as well, but I don't like transparent
I don't like transparent windows.
because it's adding visual noise, right? And this is to the extreme.
The interesting thing is, there's a couple interesting things he says, but this keyboard, I feel like that wouldn't be super comfortable to program on for a long period of time. I could see it's got some like modified keys or whatever. He wanted to use this keyboard because it's foldable. And one of the things he says is like, why isn't there a premium version of this? I would pay so much money for just this really easy portable keyboard. And to people watching, maybe that's something you should do because this could be the future, right?
Yeah.
So just carry around a keyboard.
Like a full mechanical keyboard, are you imasoning? Like
You know,
tic-tac?
it's something portable that makes it really, really easy to type at full speed. This kind of reminds me of Raspberry Pi released a keyboard that was a full computer.
Yeah.
So you just plug in a monitor or whatever.
Yep.
Kind of a similar vibe.
I'm getting a similar vibe out of it. The other one would be the AR versus VR glasses. I've seen plenty of VR headsets that have passed through in order to do the augmentation, or you just turn it off.
I think there's one right there on the ground.
Oh, is this a MetaQuest?
Yeah, it's a MetaQuest Pro.
Wow. Okay. The MetaQuest. I mean, as far as I can tell, they're awesome. I tried the. Have you tried the Apple? God, what are they called?
I have not. Yeah, the Apple Vision Pro. Yeah.
That was fun.
You liked it.
I was sort of walked in there like my little brother had done it back home and said, "Look, Matt, you're gonna be mind blown. Just give it a crack. You know, you're obviously not going to buy it. It's too expensive." And I went, I might buy it. Like I didn't because it's, you know, I was just talking about this, the great value of my bottom.
What is an Apple Vision? Did the price change at all, or is it still?
They were $3,500 when I had a look, which is just for a monitor, basically. Not happening. Like no ways.
Oh, this is an Apple page. They're not going to show me the
Yeah,
price.
you have to press the buy button in the top right.
Okay.
But oh my god, yeah, 3,499.
3,500.
But boy, like honestly, mind blowing. Like gave me chills during the demo. I was like, man, I want this experience. And then I was like, actually, you know, for this much money, I could just travel and you know.
Let me slow you down, Matt. What's your chill bar? Right? You said
chill bar.
Apple Vision Pro gave you chills. What else has given you chills? If you get chills to a great breeze in the morning, maybe this isn't that big of a deal. What's another technology that
Another technology? That's a hard one. Early days of driving the Teslas.
Okay.
Like you really punch one of those throttles. Oh yeah, that's exciting.
All right. That's a pretty high chill bar.
Yeah, mostly outdoors things, like mostly going camping somewhere just absolutely gorgeous, getting to the top of a cliff, or like cycling really hard and getting somewhere just like crazy.
Yeah.
It's like, but that's the thing.
It clears high.
Yeah, this thing is, though, it transports you there in a legitimate way that it gets not quite past the uncanny valley because the edges are a bit blurry and like, you know, I've got wonky eyes and all sorts. And so my contacts are all toroidal and but it's so close that you're just like enjoying yourself in the most beautiful places on earth. And it's done an 90% job and 80% job of transporting you there. Or courtside basketball was the one that I was like, oh my God, I don't watch sports myself. I've loved playing them my whole life, but I don't watch them. I might watch basketball if I got one of these.
Yeah,
So cool.
I can see that.
Yeah.
I think one understated thing about VR headsets like this that are able to project a monitor is it's probably really good for your posture because so many people don't even realize it, but their eyes are getting fatigued and they get a little closer to the screen.
Yeah. Yeah.
And the screen is almost certainly not at the optimal distance. Like maybe it's close to the optimal distance, but it's probably not at. Some people say it's like 3 meters is the optimal distance.
Wait,
for a screen.
wow. For the lenses in your eyes, or
For like eye health, like for a screen that's wildly impractical unless it's in VR. But just like for eye health in general, having things 3 meters away is most natural.
that's so interesting.
I can't source this because I probably read it on Reddit, but
The posture one's interesting too, because have you ever ridden a motorbike much in your life, or?
have I ever ridden a motorbike? I think I rode a dirt bike for like 5 seconds once.
Okay,
That's
yeah.
crazy. I just realized that there's an entire thing I haven't done.
Not yet. Not yet.
Not yet.
So you can a motorbike helmet is typically like 1 to 2 kilos, right? Like they're pretty heavy, so a couple of pounds,
Yeah.
right? Significantly heavier than this. And people keep talking about their neck fatigue and this and that. So I get wind fatigue on my head of just the torque backwards, and you have to push forwards on a motorbike. But the weight of the helmet is not fatiguing.
Yeah, if it's balanced, right? It should
Very
be
balanced.
okay.
Yeah. So I want a hard shell VR helmet, and it'll also help when you inevitably run into a wall playing video games.
Yeah.
And then you can, I think it would significantly offset all of the discomfort.
That's a good point. It reminds me of this phenomenon where, so sitting is bad for you. We all kind of know that. Standing is better, but it's also like not so great, or it fatigues you and stuff like that. A lot of people get less fatigued by having a walking treadmill, like actually walking, right?
Yep.
So it's not always intuitive, like how things are ergonomic. It's probably not the weight as much as the balance that's and I guess it's ugly to put on a helmet, but I mean, wearing a helmet isn't that crazy. A lot of people occupationally wear a helmet for 8+ hours.
Yep,
right? You know,
absolutely.
I could wear a helmet.
I think I could hook it up. Okay, and so what was the conclusion of the AR glasses? Did he make similar complaints to us? Or?
So the conclusion for this guy who has this VR helmet, his or worked on VR for 2 weeks, his conclusion was basically like, this is really working. And I'm probably going to keep doing it. And it's not like he actually liked it quite a bit. Let's see what he had to say exactly. Yeah.
Concluding comments. Am I going to keep using this? I'm safely out of the novelty phase, and incredibly, I think the answer is yes.
Yeah.
Oh, there you go.
Yeah.
Okay.
So that really made me want to try it. I feel bad because Nreal is not, they don't, I guess they've been around long enough where they're sort of a pioneer in the space, but they also feel like the least ambitious VR AR company in some respect.
Because they're just trying to be a just external display for your...
Yeah, because it's really just an external display. There's no, it's not like Apple Vision where it kind of
maps to the world.
Yeah, exactly. They don't try to map the world or anything. It really is just a screen in front of your eyes.
In that case, if that's what they're doing, if they could delete the background and I could just wear the screen on my head, that would be ace.
So he mentions that Nreal sells different models, and in one of the models, I think you can slide something, or maybe it's done in software, but you can darken the background. So you can make everything dark except the screen. And he says it was much better than using a laptop outdoors. It was actually very readable outdoors.
Oh, that's okay. That's interesting. I mean, I don't normally code outside, and I think I'd get sunburnt if I did.
True. There is such a thing as too much sun. Can you imagine if programmers had a problem where they were getting too much sun?
Too tanned.
Can't imagine their reality.
They're currently pretty pale on average, myself included.
Okay, so before we got started here, we really wanted to talk about PCB fabbing. I am
specifically PCB fab in-house is a big part of it.
PCB fab in-house. I'm really interested in small runs because I just want to have my prototypes yesterday. I don't want to wait any time at all. So the latest hot thing on Twitter is people using lasers to cut their PCBs, which is being shown here. So can you explain, for your knowledge of what's going on here, because I actually don't know much about PCB fabbing, but is he dissolving copper with that laser?
Not dissolving it. So we have actually done some R&D on this. You can take a high power UV laser and ablate, a high power fiber laser, and ablate the copper directly off the surface of a PCB. So if you haven't seen a PCB fab from basics, it's, I think the Strange Parts YouTube channel has an incredible video on it. He did a tour of the JLC factory and I think maybe PCB Way, in depth, 20 minutes, like looking at the whole
Strange
line.
Parts is fantastic.
He's fantastic.
Yeah.
So I strongly recommend that.
Yeah, huge recommendation to Strange Parts, yeah.
But that's, so the typical way these come in is you end up with a piece of, it's basically a piece of fiberglass with some fire retardant in the epoxy, so that when inevitably something smokes up, it doesn't set the glue in the fiberglass on fire. And then they laminate 2 pieces of copper foil onto that board. And that's how a PCB fab themselves will receive the board, whether it's from like Samsung or whoever manufactures these PCBs. That's how it comes in blank. And then typically use a chemical process to dissolve the copper selectively off either side of those boards, and then you basically glue on more boards and dissolve the copper off and glue on more, etc. And that's how PCB fab is typically done in an incredibly abbreviated sense.
Right.
Now,
so a lot of chemicals.
Lot of chemicals. Yeah. So you're using what's ferric chloride acid, which is like an iron-based.
So nothing that would hurt you.
Yeah, no, it'll hurt you. It's like a 3 on the health and the fire triangle. Okay. So it's like bad, like don't drink it, but like I wouldn't want to use it in my home, but I'd happily use it in a workshop.
Okay. You should be wearing gloves.
You definitely should be wearing gloves. It's like quite strong.
I actually thought it was more dangerous than that.
No. I did it when I was probably 10 or 12 for the first time. I made my first PCB when I was about 10 or 12. So shout out to mum and dad. Thank you for letting me do that. But
wow.
Yeah. It's also plausibly regenerative. So you don't actually need to discard these chemicals afterwards. You can actually, because it goes from ferric chloride 3 to ferric chloride 2. And so you can actually, by reoxygenating it, and I think performing, if I remember correctly, electrolysis on it, you can pull the copper out as a metallic copper again via electrolysis.
Oh, cool.
And then regenerate the acid, which is really cool.
Yeah.
Plausibly a semi-closed cycle thing where
you're slowly making this process like more appealing to me. Like I've always been super opposed to chemical processes. I'm like, hey, look, electrical engineering, sure. Computer engineering, all right. But chemical engineering, keep that away from me. But that actually doesn't sound that bad.
It doesn't need to be horrifying. But the alternative here, and this is so interesting because there's so many technologies in this space, but this big alternative that started taking off, and it's taken off because of a really novel rise in the cost of high power pulse lasers from China. So these are all based on fiber lasers, which
I wanted to ask about that. I have no idea what a fiber layer is.
Okay, yeah. So are you familiar with the like old school, like you have one full mirror and one semi-transparent mirror and a laser cavity?
I don't know much about lasers. Apparently, I was like UV. That's a wavelength, so I know that.
Yep. Okay.
But no, I don't know.
Okay. Yeah. Broadly, how most lasers work, any resonant cavity laser, you have, there's diode lasers and resonant cavity lasers, and I don't know much about diode lasers, so I won't pretend to. But resonant cavity lasers, you have and I might actually be misusing the term for fiber lasers, but roughly speaking, what you do is you have a fully silvered mirror at one side and a semi-silvered mirror at the other side, and you pump the laser with some energy, and that's either in the case of typically some light input, and then all of a sudden, and you excite all of the medium within your laser. And for a fiber laser, that's a doped glass fiber, typically with yttrium. And then you basically exciting some of those yttrium ions by pumping it with laser diodes, and that just energizes these yttrium, the electrons on these yttrium atoms. And then finally, when a photon of the right wavelength passes right by that atom, it will encourage that to immediately dump that electron all the way back down to its lower energy state and emit another photon of the exact same phase and wavelength as that first photon. So you have a fully synchronous light beam. And then eventually, the cool thing about a fiber is that you can basically wrap this really long doped fiber up. You can pump it a bunch, and you can pump it with multiple diodes, and then you have a final pulse triggering diode. And so you can imagine accumulate a bunch of energy like a capacitor, and then you can trigger that all at once with a pulse from the central diode and end up with a very, very short pulse of light coming in.
Okay.
And that's really cool because in applications of ablation like this copper, you can very, very quickly heat up a tiny, tiny little piece of that copper, vaporize it, and blow it straight off the front of the.
Wow. Okay, so ablation is vaporizing.
It's basically vaporizing a little crater out of the front of it. But you can imagine these pulses, and actually, if you put it under a microscope, these pulses are super close together. So on macro, it just looks like a line,
right?
But they're actually a whole bunch of small.
There's a bunch of like circles. Okay, interesting.
So you can imagine, and it's very Star Wars-esque with these pulse lasers, because really fast compressed pulse laser, you can do weird optics shenanigans to actually compress the pulses after you generated them. But even without that, the actual rod of light that you're shooting out is, if I remember correctly, about 60 meters for these cheap Chinese.
Really? Huh.
And light moves fast, right?
Right.
So you can imagine a 60-meter length of light down the street. Obviously, you can't see it, but if you could freeze time and see this light pulse down the street, I think it's so cool.
Yeah, that is pretty cool.
Yeah.
So we're zapping away the copper.
Yes. So that's what you're saying here.
The first thing I'm curious about is people on Twitter, they seem to think this is totally okay for 0402s. The only thing I've heard is that it has some calibration. You can like burn too much or be too strong or something like that.
Yep.
Why? I'm wondering why people are doing the chemical process. Is it more accuracy? Is it that tuning? Like, the cheapness of lasers is why this is coming up now, but is it realistically the future in any way?
This laser ablation is an experimental technology that's never been applied to any mass production. So from the get-go.
Yeah.
There are a couple of companies that I'm aware of that are laser ablating some flex PCBs for protraction purposes, which is like very, very novel. And this is new and novel, but the way it's done is chemical processes today, and the reason for that is just cost.
Gotcha.
It's super cheap to just like the Formlabs printers, how they have selectively cure a resin.
That's right.
You selectively cure a resin on top of the copper that protects underneath it, and then you soak it in ferric chloride, and I think there's actually new etchants for modern PCB. You selectively remove that copper. It's just a photolithographic process.
Right. And photolithography is very, very precise.
Very, very precise. So it's precise, it's inexpensive, and it's very well developed. And you can make thousands of PCBs at the same time.
Right.
Whereas this, you can see it's eking out
slow.
a single tray.
Is it and I don't know much about these laser systems. Do people typically have a gantry to move it around like a CNC, or is it like there's something else guiding that laser?
Yeah. So in this case, actually, it's what's called a galvanometer, and so these galvos for short are basically it's a mirror, or typically actually two mirrors that change their angle slightly.
I see.
It's the fixed laser source, and they just kind of reflect it around at slightly different angles.
So those are very accurate, I would imagine. And as you get closer to the work piece, it probably gets more accurate. Is that
yes, exactly? Because it's a big cone. Okay. And you also need a fancy lens to take this now conical light beam and then actually focus it to a flat plane.
Yeah.
And so there are fixed lenses that you can typically purchase with these types of galvo machines.
You know what's funny is I didn't know Matt knew this much about this, and how I'd be in hot water right now with a lot of questions if you didn't know so much about it. It's pretty cool.
No, please.
The material, does this work on like normal PCB boards, or are there special, like, okay, so the copper that you're getting in, it's got some substrate between the copper. Is that right?
Yeah.
Do you need a special substrate for this to work?
You don't, but you can actually get better performance with different substrates. I
see. Okay.
Maybe we should take a step back and actually discuss why this is so interesting as a process, and why we're both and Twitter is so excited.
We're just going deep into it. Yeah.
So I think there's an incredibly good analog to be drawn here between where 3D printing was about 15 years ago, roughly. Maybe, well, how old am I now? Yeah, about 15 years ago. and where PCB prototyping is today.
Right.
Like 3D printing 15 years ago was the sole domain of a couple of really high-grade technologies that were exceptionally expensive and patent protected in a way that no one else could reasonably access them.
Absolutely.
And it was not a prolific engineering technology at all.
There was RepRap, right? RepRap was, everybody associated RepRap with like barely working. Like
Yep.
it was like the equivalent of somebody pretending they could ship a product with like a breadboard with like just
Yep.
wires all over the place. Like no, that you can't do something real with that.
Yep. Yeah. So even if you look at just a smidge before RepRap, right? RepRap changed the game because before that, there were somewhere in the order of typically $200,000 machines.
Yeah.
And they had the powder bed machines, so SLS and SLM. They had SLA, so stereolithographic machines with the UV. And that was thousands of dollars a liter for the resin, right? And the powders were expensive too.
That's crazy.
So it was super expensive for the volume.
That's
of these
much
parts.
different than now.
Yeah.
Yeah, I think with the bamboo, you can literally just buy cartridges and you just slap it into that machine. It's kind of satisfying. It's like a chunk and you're good to go. How much does that kind of cartridge cost?
So I actually just bought myself a
nice.
new bamboo printer yesterday.
Matt coincidentally having all the knowledge I need.
I spent $1,300, including shipping and taxes to the States, because you guys don't quote things with taxes, but you should. So,
Not wrong.
and I bought, it's $20 a kilo for PLA.
Okay.
So that's about 2.2 pounds. So it's $10 a pound.
Wow.
For plastic.
2.2 pounds. I'm trying to imagine a product that's 2.2 pounds, and I would pay $20 to get
right.
like a prototype. So
Cheap enough you don't need to think about it.
Yeah,
In my
exactly.
early engineering career, we typically we were pedantic about 3D prints because they were in terms of both time and cost, expensive. They took the same as today's fabs. They took 2 weeks to get back.
Yeah.
Right.
Yeah.
And they cost hundreds and hundreds of dollars per run. And so you would go into excruciating detail to make sure they were right. And the beauty of modern 3D printing is you don't need to care and scrutinize as much. And that means you can iterate faster and so you can learn more.
Yep.
Which is incredible.
Absolutely.
And so to tie that back to the PCB fab, right? That's where we're at today. There are PCB LPKF or LPKF. I always get the acronym mucked up. They make laser ablating prototype machines exactly like this.
Oh.
Those packages are $200,000. Almost bang on.
Interesting.
Yeah.
Okay, very
right.
similar.
And outsourcing PCB fab, a little bit unlike the 3D printing, because the Chinese vendors is really cheap these days, right? But the lead time is still there. It's still
That's right.
at least 5 days. And if you get assembly, I found about 2 weeks.
That's right. That's right.
Yeah. What this plausibly offers in-house, which is so exciting, is, and I think these guys, we're just getting past the RepRap stage just suddenly, but I don't think there's been a good RepRap equivalent of you can genuinely, and anyone can, fabricate a PCB in their own home on a couple of hour scale with sufficient reliability for you want to do it.
Yeah, it would be amazing for prototyping. It's kind of crazy how much 3D printing enables and how much more will be enabled when we have PCB fabs, and especially these two things together. Like you can ship real products
on a day scale.
On a day scale. Just crazy. It's also, there's so much to talk about here, but I think the linchpin of these PCBs to me seems to be the vias. So I wonder, so what do you think is the best way to solve a via? And then I have, as a teaser, I have a guy here who has claimed with his proprietary process he has solved the via problem, and I want to try to reverse engineer it for fun. So but I'm very curious, how do you see vias happening? And some context on this is like how I see people doing vias with these like desktop printers today is they will like literally punch in these like plated, I don't know what you call them.
Rivets?
Yeah, you like rivet the vias.
Yeah, I've seen.
Or you use a chemical process. You use, you kind of flow some chemical through it and it plates the inside of these holes. Yep. But that requires a couple steps because you might have some non-plated holes and stuff like that. So you got to manage all those steps then. So how do you think vias can be solved?
I think that you need to use a chemical process, unfortunately, for your disdain for them. Rightfully so. I don't want these chemicals in my home either. Yeah. Right. But I think you need to, because you need genuinely good conducting copper that is similar to the like perfect, whatever, it's like 5 nines, or no, so it's 4 nines pure copper, like oxygen-free copper that you have on either of the layers, because you need that conductivity as soon as you're serious about making a circuit. You can't just have the thing overheating.
Yeah. That's a good point. When people are riveting their vias, the conductivity might not be great, and it certainly will be variable.
And it's also manual to the point where
Very manual.
you're unlikely to get penetration on a massive scale.
Yeah.
Yep.
I have, I'll throw out like a really wild theory. This is going to be like a real wild card, but for a while, PCBs and chips were kind of similar. They were kind of hand in hand before transistors got really small, and then they were like, let's break up this process, and PCBs became a totally different process than chips. But there were a lot of similarities, the lithography and stuff like that.
Yep.
My proposal for a version of the future is we have another stage, which is like your compute boards.
Yep.
And those compute boards, which are a PCB with a processor and a lot of peripherals, go into wiring boards. And wiring boards have no vias. They use 0 ohm resistors and they connect everything together like that because vias are so annoying to deal with.
Interesting.
So,
okay.
You've heard my vision. What do you think of this crazy future? And by the way, obviously, routing these 1.5D boards would be terrible. So it would have to be automatic.
For prototyping processes?
I think this would be for prototyping. So you could essentially combine boards together, or you can put down, you have basically a budget of components you can put down before this really isn't going to work.
Yeah.
But it could work for, I don't know. I mean, what is there? You're not going to have like plated components, right? But like, I don't know. What do you think? Crazy?
I mean, I think you can get away with it to an interesting degree. But as soon as your trace properties start to matter, like you've got some, so this is the beauty of your pitch, is that you don't need to deal with high-speed signals because you put your DRAM right next to your sock, and those two things can speak,
Yeah, that's like worrying about what's in the chip.
Yeah, it's like, you're right. It's like worrying about what's in the chip. I think, I actually don't think through plating and therefore vias needs to be as big a problem as it's been made so far. And I think that, as I said, I think we're at the RepRap stage and we're seeing like a lot of really gnarly prototypes coming out. Soon someone will be the form labs of in-house,
and they'll have
PCB
a chemical process that works.
Yes, and they'll have a chemical process that works.
That's a good point. Yeah. Okay, so let's take a look
Let's take
a look at this proprietary process. I teed it up. And we've heard so this is somebody doing.
That's a regular lithographic mask by the looks of it.
Okay, so this is regular
vanilla PCB fab.
Yeah, so they're preparing to do normal lithography. Okay, this person is the person who says they have a proprietary method. So is there any commercial interest in a Desktopish full cycle PCB printer? I proved out all the processes for a fully automated chemical-free production for 2-layer PCBs with trace space via as small as 75 microns.
That's pretty good.
It could be relatively affordable, but not hobbyist priced. And he's got a board here. And
look at this. And there's blurred a section of it.
Oh, interesting. That might be a calibration thing. Maybe that's the giveaway. I don't see anything wrong with this. I don't know the size of it. So not too much to say there.
I don't see. Do you mind going back a smidge?
Yeah.
So we got some sharp corners. I was going to say I don't see any of those. I see some patchiness, interestingly, around the edges. If you look at some of the blobs, you can see. It looks like there's
some serious patchiness, actually.
Okay.
We have to know the scale of this, but I don't think this is that small. I think the 75 microns, I don't think I buy it. By the way, how
you don't believe this is 75 microns, or?
I don't think it could reliably do 75 microns based on this picture.
How big's this picture?
See, I'm like guessing based on the texture of copper. They don't have enough information. They're clearly trying to keep their secret sauce secret.
They're trying. Yeah, he's trying. Yeah. Okay, can we see the hole? I think.
All right, so this is the hole. So they said they used a non-chemical process for this.
I reckon he sintered that.
I'm so confused about this because, first of all, blue. What? What's blue?
Bluish. Yeah.
What's blue? And it doesn't. Everything looks a little bit weird about this, right?
I reckon he used powdered copper and he sintered it.
Whoa.
And the reason I say that is because if you look closely at this photo, it looks to me to be a whole bunch of small spheres compacted together.
Yeah. You know what? That could be it. It could be basically, wait a second. Wait a second. It's probably all, I bet these are all sintered, right? Okay.
It could be. I mean, I don't know, obviously, but
Thinking about this, could he be shooting copper balls, to put it simply, and then sintering them? Or no, you would lay out copper balls.
plausibly. So you could plausibly lay out a layer of copper and then sinter it. I don't know how you glue it to the PCB.
So that blue on the side, is that glue?
I mean, it could be some adhesive. Yeah. But even this, look at all this. So that whole set of adhesive seems to have little spheres in it.
Yeah. So it's just like sintering over and over again with different materials. Could that be it?
Well, it would be a tough one because sintering copper, you would need vastly higher temperature than sintering the plastics, right? And so how do you not destroy the underlying plastic layers? Or like, he could be doing this onto a ceramic substrate, which is plausible, right? Mm-hmm. But you need to bind the copper to that substrate. Do you have an adhesive under there? Like what's
the walls of the via are also very smooth. So I don't know.
Do the comments yield any wisdom?
Right. So this is, yeah.
We should explain. So for audio only, we are looking at two photos, one of a PCB and one of this hole. And I mean, it looks like a vanilla PCB that's a little bit wonky. Like there's some small artifacts that are off the side of it. And this, look, I'm describing it as best as I can, but it's a hole. It's copper coated. And to me, it does look like it's sort of formed from powder, it's sintered or something like that, because there's some distinct graininess or baldness to it.
Okay, so the first person says, and you were mentioning this is what LPKF does, 150 micron limit, okay. But what they don't explain what they do though. Proto laser alone, yeah, can you parse any of this? Starts at over $100,000.
So the proto laser is LPKF's like cheapest, lowest cost laser.
Oh wow, and that's $100,000.
Yeah, dude, I'm telling you. So that kit to actually fab a PCB with a proto laser and like a couple of other small tools beside it's like a 200 gram package.
I did not know that. I just assumed it was smaller.
No.
Wow, that's crazy. And this person is saying they make same day, so they're actually doing this. And 150 micron vias is the limit. This is that a small via? I'm trying to think. What's JLC PCB's limit on vias?
That's a smaller than a 0.2 mil visa. Sorry, via is like a small via. So this is impressive.
That's really good. Yeah, I'm thinking I usually manufacture at 0.5, which is 500.
Yeah, micro. Yeah.
Yeah, so they're doing 150 microns. And this is a guy who actually works at, well, he doesn't say where he works, but he actually works at a fab, I guess. So that's good to know. So we know the laser process can do 150 and he's got customers, presumably.
Yeah.
So,
I'm keeping the IP because I would like to pay my rent and buy my food.
Yeah. That's when I was like, okay, proprietary process.
So this is an interesting one though. So have you ever read a book called Guns, Germs, and Steel?
No.
Oh, okay. It's a classic, and I'd never read it before. It's on the history of humanity and why in the modern world, Eurasian peoples originally Eurasian peoples have now become the like dominant peoples on Earth and like overtaken the US and these days China. The most like it was now millennia ago, but people of Chinese origin took over a lot of Southeast Asia and Asia in general.
That's a good point. Yeah, I wonder. China's had probably the biggest population a couple times.
Oh yeah, most of human history.
Yeah.
It's a really. Do you mind scrolling back down to that comment there?
Yes, the proprietary one here.
Yeah, the oh wow.
A lot of people are interested in this. So everybody in this thread is like, oh, hey, I want to do it. Let's chat.
Yeah.
There's a lot of people interested in PCB fabbing.
Super people. But one of the things this book brings up is that a lot of these inventions need to have a confluence of factors, not just right to decide whether or not the technology is plausible, like agriculture was invented a number of times, it also needs to make sense for the people in those circumstances to actually want to use it.
Yes.
And I think that this is really funny because it's so well illustrated with PCB Fab, because there's a decent pick and place on the market, the Lumen PMP.
Yeah.
It's not bad. It's like decent, but it's
I think it can do 0402s.
it can do 0402s. So it's good, but it's not great because the software holds it back. Like OpenPMP is good, but not great. It's really quite annoying to use. And now the PCB actual fab half is also very mediocre. And so you've now got these two compounding mediocre factors that need to overtake just ordering it from JLC.
That's right.
Or just ordering it from one of these, plausible US manufacturers.
Yeah.
And so it's really interesting to see people come up and say, hey, is there any interest in this hobby thing? Because like in what you're able to do today, the answer is going to be this blunt return of like, someone else does this better, I don't care.
Yeah.
You have to be very willing to walk over the big crevasse to traverse the canyon and actually make it onto the side of it being net useful.
Absolutely.
Not going to be for a while, like RepRaps weren't. They were crap for years.
Yep. Absolutely. Could still be a while, but yeah, it was interesting when the JLC briefly had 200% tariffs, and a lot of people started flocking to U.S. manufacturers discussing it. It's sort of a funny thing. I don't have a link for this, but on Reddit, maybe I can find a link. It's kind of a funny story. But when this JLC PCB tariff thing happened, a bunch of like random companies started spinning up that were basically just doing PCB fab fraud. So let me find the thread.
Oh, in El Salvador, no.
Oh no. Okay, so the title is El Salvador PCB manufacturing scam.
PCB builder.
Yeah. So I guess it's called PCB builder. And basically when the 200% tariffs hit, this guy said, hey guys, I started a fab in El Salvador. You can order from me. It's fully automated and we'll send it to you. We're just like JLC. We've been setting up for years or something. Mm-hmm. And somebody actually ordered from them and they got their board and it was a JLC board. So these guys are kind of just middlemen for sort of just passing through from JLC.
Why do we care?
So,
bluntly, why does it? So these people feel like they've been scammed, but like,
you got the quality you wanted at the price you wanted. So
you got the quality you wanted.
Did you really get scammed?
Yeah, like if they put a sticker on the box, did they assemble it there? Like, what's the barrier?
No, I mean, this is what's going to happen with. I mean, Chinese companies do not just have bases in China. A lot of them, I was at PCB West last year and a lot of US companies were setting up shops in Vietnam and all these places, right? Chinese companies do the same thing. They set up shops in Vietnam and stuff like that, and they can ship things through there or ship their materials, whatever.
Yeah.
And so having this extreme tariff on China, it's not high enough or it's too high, so it incentivizes middlemen to do this.
It's also too erratic because it legitimately takes years to build up a hardcore manufacturing presence somewhere, even if you know what you're doing.
Yeah.
Like it's not just a snap of the fingers.
Yeah.
And so when they come and go in 60 days, every company who is wise is not like, time to set up US manufacturing. They're like, well, I guess I'd better see how stable this is because lo and behold, they seem to have disappeared at least for the next 90 days.
Yeah.
And so you end up just riding the waves of this erratic government rather than actually trying to play by the new, quote unquote new set of rules.
Yeah, absolutely. One of the interesting things, I follow the CEO of Circuit Hub on Twitter, and they had so much business from the tariffs that they actually had to shut down or they had to stop taking orders.
Wow.
So
this is a legitimate US manufacturer.
This is a very legit US manufacturer. And I think they do instant quoting. The pricing is pretty reasonable. Let's take a peek at the pricing here. This is turnkey, so you can get it fully assembled. And you can see for $5 in 3 days, you can get 1,000. You can get 5 PCBs for $1,000 in 3 days, and that's just like a typical quote.
Excluding parts. Okay, so is is that for the 2-layer? Because they've got a few things above this. What are these order prices?
Yeah, they've got 4. Okay, so let's click 4 layer. So 4 layer is going to add $300, and then 6 layer is going to add 6 layers $5,500. 2 layers $1,000.
Wow. Okay, so it is very good for the US, and I love the transparency of the pricing, but by God, it's still an order of magnitude. It is literally an order of magnitude more expensive than China. In fact, actually 2 orders of magnitude more expensive.
And also we're on low design complexity, but if you increase design complexity, I mean, good on them for being so transparent. Actually, it's all the same. Yeah. Okay. High is 6 layer. Okay.
Wow. Okay. But look, yeah, really good on them. This is awesome. And honestly, I think that my honest take on the tariffs is that they're not necessarily an evil thing. It's my problem with them is how they've been executed and what they've been executed on.
Yeah.
Because if you demand that manufacturing is done domestically, we've proven numerous times the only reasonable things to do that, to put tariffs on, is things that you decide you need to have for security bases, which is a reasonable argument about this. We can say that you need to be able to manufacture electronics. They're critical to the success of a country.
Right.
And that in some, bad future scenario that we'll get cut off from this prototyping, our innovative tech companies wouldn't be able to do their jobs. So we need to subsidize domestic manufacturing by placing tariffs on external. Okay, I buy that argument. But in order for someone like Circuit Hub to legitimately actually get an edge here and get these prices down through volumes, which is what they'd need to do, they need stable tariffs over the next 10 years kind of thing.
Yeah, I think it's the reason I like Circuit Hub is I think they're doing their best and they're charging what they kind of need to charge to sort of maximize their investment. They can charge these prices because some companies are we actually cannot handle the variability. They're afraid of the 200%, 30%, all of that. And so they're willing to pay a premium.
And even beyond that, there's a lot of things that you simply don't want to ship overseas for an IP security or for the sake of being able to, sometimes you do just literally want to ship ICs to someone, and as soon as you deal with international shipping of electronics, there's some things that you can't legally ship, and ITAR comes in, and
absolutely,
yep,
yeah. So the tariffs are creating really interesting dynamics here. We've got middlemen doing tariff fraud, and then we're do we even care about tariff fraud?
Selfishly, as an individual, you're not going to care about tariff fraud as long as you have plausible deniability.
It does mean your supply chain isn't robust if you have tariff fraud in your supply chain, right? And
you can't do it for anything in production, obviously. It's for prototype.
And ostensibly, you could get in trouble if you were knowingly doing it. Maybe.
Yeah. Now that I've said it, I'm screwed. But
but yeah, it's probably going to happen a lot. We won't really know if our supply chain is resilient because. There'll be so many middlemen. But the tariffs have been reduced. I think they're 30 or 50% now. So,
which on $2 PCBs is easily stomach.
Yeah. So it's good. My little keyboard that I was ordering was $80 pre-tariff or with 20% tariff.
Pre-assembly, right?
No, that's post-assembly.
No way, that's assembled.
Yeah. So I mean. That's pretty cool that you can get a custom electronic device fully assembled.
Yeah.
Well, okay, so I will say with keyboards, you have to buy those switches, and those switches are pretty expensive. So I didn't count the switch price.
Yep. Yeah. Okay.
I put that in every time.
Nice. Maybe just as we wrap up, I would love. Is there any more of the tabs you have open on PCB Fab or PCB Prototype in-house Fab?
Yeah. Let's check that.
So
that's
this is a mask, which is.
Yeah, we can briefly look at the mask. I don't think there's...
What about... Yeah, this is just a standard lithographic...
Standard mask. So these guys are using a chemical process.
Yep. Which, I mean, it works great. It's a well-proven process.
Yeah.
What about Thomas, the next one to the left?
Oh, yeah. This is going to be a little awkward. So this is actually the guy who we just saw comment on the other post. So this guy is... he's working at a fab. Using ablation. And he says, the biggest issue with design EEs today is the lack of understanding of the manufacturing side. Below is a typical HDI stack up. So common EEs do it without even thinking. Just one via through the entire stack. Saving costs. What is he talking about?
So
I looked at this and I'm like, I barely know what I'm looking at. There's different layers here showing my EE quality. Okay, dude.
this is this is a cross section of a PCB.
Right.
Looks like it's a 8-layer board. I want to say we've got these 2 central layers and then 3 outside of it.
8 layers.
Yep.
Yeah.
And roughly what we're looking at here is so each of these cones, basically, or these sections of a trapezoid, represents a separate layer of, it's a high density interconnect is what HDI stands for. And so what they've said in their CAD software is there is a via on this layer between this layer and this one, and there's a via here and here, and there's a via here and here between each of the layers, rather than just saying there is a via all the way through. And how that exports into manufacturing is that each time they add a layer, they'll separately drill and replate it and separately drill and replate it, where they could have obviously just replaced this with a single drill and a single plating.
I just assumed this was some weird artifact of the manufacturing process. No, this is like a really dumb export mistake. So we've got all these so this HDI, I should definitely know this, but these HDI things, I assumed so the middle section here, that's like electroplating, that's a chemical process, right? The other ones aren't a chemical process. What's going on there? How are those vias?
So the horizontal lines that you're seeing are each of the copper foil layers, as I was describing before. These sort of trapezoids between them are the through-plated vias. And so as they add each of these layers, they're separately drilling and adding. That's why they're conical, because they're separately drilling and adding each of those conical or trapezoidal layers. Whereas instead, if you just punched a drill through the whole lot, once they were stacked together, you do an overall plating to do the most outside vias. You would have saved all of those internal manufacturing steps.
That's so interesting.
Now, as a counterpoint to this bloke, because this is a very much an old mindset kind of problem, he likes the old LPKF, single day fab, 200 grand, no problem. This is an old school engineer, an old school hardware engineer. Now, why am I as an engineer, hopefully for prototyping, given that this is something that you might want to optimize out on mass production,
right?
Why could I possibly care when it's not influencing the price?
That's going to conduct.
It's going to conduct. It's going to conduct perfectly well. It's almost pure copper, so it's good quality. It's not going to impact the function of my circuit at all. It's not going to impact any of the electrical characteristics in any meaningful way.
We're basically looking at like the compiled assembly code or something like that. You know,
yes,
we don't care.
Yeah, exactly. No, we are.
Does it work?
Exactly. No, we're looking down at the assembly code and complaining about, well, if I wrote it manually, I'd optimize this differently.
Right.
And it's just not necessarily relevant.
Yeah.
You know, I could be, and that's not entirely true. When you get bespoke massive orders of like tens or hundreds of thousands of units, you are doing this type of manufacturing optimization,
right?
Because then it matters.
Yeah, because even a 0.0001% failure will happen, and this is clearly going to be more failure prone because
it's a repetitive process.
Right. Yeah, we're looking at like 7 operations instead of 1 or something like that, right?
Yeah, totally. I would love to wrap up this episode with a short conversation on the technologies aspect, because we started obviously looking at so it's called structuring, the process that they were doing via either the laser ablation or the chemical etching, right? You cut the traces out, it's called structuring. The analog here between the early 3D printing days of whether, there's a war between the SLA guys who want to make the Formlabs-esque printer and the FDM guys who are like, well, it's cheap to make a hot end at home. We're seeing that between the laser ablation fiber laser guys with the galvos and whatnot, and the at-home etching, right?
Yeah.
And I think there's a beautiful world here where both of these technologies actually end up at their mature point, and you can combine them, interleave them, use them one or the other depending on what your part or your PCB looks like. And I think the competition here is rich, is powerful, and is a great sign that there is actually an ultimate outcome. And it's not that one's better than the other. Like, my money says the laser ablation is the earlier one, analogous to FDM.
Yeah.
But I think some company like Formlabs will come through with an incredibly well-packaged, low-touch, safe enough, low-odor version of the chemical processes. and you'll be able to manufacture these 6-layer high-density interconnect boards at home in a similar fashion. And I'm excited to live in that future.
Let the games begin.
Let the games
it's very
begin.
exciting. Matt, thanks for coming.
Pleasure talking to you.